Okay, hey Trig, this is the first section that we're going to do during this break, 3-4. We started talking about section 3-4 the last time we were in class, and we filled out this chart right here. This is going to be kind of what I'm going to make reference to when we go through the notes. I'm also going to start by filling out these 4 columns right here. So if you have this sheet, make sure you get it out, as well as your notes for section 3-4. We're going to go through that. The notes will actually go fairly quickly, so this should be kind of a short video, okay? Let's fill out these columns first. I call this these 4 columns right here kind of like your cheat sheet, because as soon as you can kind of identify what is happening to the function, it makes it really easy for you to graph and identify how you're shifting it, up, down, left, right, that type of thing. Okay, so when you're doing a vertical translation, this first box, 6 units up, we said y equals x changed to y equals x plus 6. So that involves adding the 6, and we're doing it outside of the function. The 6 is just tacked on to the end of the function, okay? The minus 5, when you're going down 5, is the same thing. We're adding or subtracting, and we're doing it outside of the function. Now, the thing that changes when we're going left and right, we're still adding and subtracting that 9 and 4, so that part stays the same, but now this part physically goes inside of the 2x plus 3, so that is an inside of the function. He's inside of parentheses, okay? Vertical stretch and compression, this 5 and this 1/3 is being multiplied by the x, so we're going to click these boxes here, and that is being multiplied outside of the function. You can really see that in this step right here, where we're taking 5 times 2x plus 3, because 5 is on the outside of the 2x plus 3. So that is going to select those 2 boxes. If I'm going too fast, you can pause this video at any time. The horizontal stretch and compression, that is inside of parentheses, but we're still multiplying the 1/2 and the 4. So still multiplying, I'm going to check those boxes, but because it's in parentheses and we literally put the 1/2 x inside of the 2x plus 3, that's an inside of the function, that x right there, okay? Now, reflection over the x-axis and y-axis, are we adding and subtracting, or are we multiplying? By plugging that negative in there, we technically are multiplying, and we're multiplying by a -1. When it's a reflection over the x-axis, this negative is just on the outside of the function. So he goes right here. Is that outside? Yep, that's outside. Inside the function is the parentheses when we actually plug the negative inside of the equation, and that goes there, okay? So the reason why I call this kind of your cheat sheet is that there's a trend for this, okay? And you don't have to make any of these marks on your, I'm just going to do a bunch of circles and stuff, so don't mark this sheet up any more than we've already done. When we're doing a translation, up, down, left, right, that's these 4 boxes. What those had in common was that we were just adding and subtracting. Okay, when we're doing a stretch or compression, stretch or compression, stretch or compression, that's when we're multiplying, okay? So that's kind of your cheat sheet of how you know what's happening with that. I'm going to erase those guys now. And I'll erase this stuff too, okay? Then you have, let me erase this one as well. And that one. Then when we have vertical translations or vertical stretch and compressions, what those had in common was we're doing that to the outside of the function, okay? So whatever we're multiplying or whatever we're adding is either tacked on to the end of the function or multiplied at the beginning of the function. So that's kind of how that worked, okay? And then we have a horizontal, and anytime horizontal is done, for one thing, we made little marks off to the side over here that you use the opposite sign, and you are using the reciprocal. So for horizontal translations or horizontal stretches and compressions, you do something funny, like using the opposite or using the reciprocal, but also those are the times where you actually plug that into the function. So those are inside of the function, okay? And then reflections are the same thing. They're both multiplying, but one is inside of the function because this has to do with vertical. Reflection over the x-axis flips it kind of from up to down, which is kind of funny because reflection over the x-axis, x goes left and right, but you are actually moving the stuff that is above to down below, or the stuff from down to below to above. So this is kind of has to do with the vertical. Reflection over the y-axis has to do kind of with horizontally translating it, or horizontal, there we go. I did not spell that right. Oh my. Horizontal. I'll just do, there we go. H-O-R-I-Z. Okay, so if we're taking something, and let's say I'm taking this linear function right here, and I am horizontal, or I'm reflecting him over the y-axis, it's going to take this guy and move him over here, and this guy and move him over here. So I am kind of horizontally like flipping him, if that makes any sense at all. So that's kind of why this is consistent with horizontal. It's inside of the function. This box right here is consistent with the vertical. They're outside of the function, okay? So that's kind of your cheat sheet. Use this chart when you're going through your homework assignment, as well as your parent functions. They're going to ask you some of that on our notes, okay? So let's go up to the top. Graphs and transformations, the first thing that they're going to introduce is a vertical shift and a horizontal shift. That's just your adding, okay? So we have the graph of g of x, which is this guy, and h of x, which is this guy. And I'm going to introduce one more thing, which is called the parent function. Okay, so we need to identify what the parent function is. Basically, that means if you strip away all of the numbers in both of these equations, what would be left over? Left over would just be, we're starting with the absolute value of x, okay? So I'm going to graph him in purple. The absolute value of x, if you need to look at your parent function sheet, right here, this is your absolute value of x function. He is a perfect v. I will try not to make you terribly nauseous in this video. So he is a perfect v, that's my parent function. Okay, then I need to identify, I'm going to do this in a different color, what the plus 4 is doing. Plus 4 is just vertically shifting him up 4. He's not going to change how wide or how narrow he is. So that's my up 4. And then I'll do this one in green. Minus 3 is just going to shift him down 3. Okay, so that's what those rules are doing. Ooh, there you go. Okay, it helps to use different colors, but you don't necessarily have to. I mean, if you want to graph them all on the same coordinate plane, you could use like a dotted line and a solid line for one graph versus the other. Like, let's say we make this one a dotted line and this one a solid line. That's okay too, okay? Horizontal shifts. Let's talk about what each one of these is doing, okay? So these graphs, let's do the parent function first. And his parent function is 1 over x. Y equals 1 over x. And if you remember, those are the boomerang guys. Okay, so he will have a vertical asymptote at 0 and a horizontal asymptote at 0. So he's going to go like this, ooh, kind of, and like this. Okay, so the thing that I keep in mind is for that original function, the place where those two vertical asymptotes come together is the place 0, 0, okay? So that'll help us here in just a minute, all right? This first function, 1 over x minus 3, a lot of people think the minus 3 is moving it down 3, but that would look like 1 over x and then minus 3 on the outside. That is down 3. So when it's inside there, just imagine that this guy has parentheses around him. Okay, and so minus 3 is actually moving him to the right 3. Okay, so I'm going to use that dot that I had at 0, 0, and I'm going to move him 3 units to the right. So my horizontal asymptote will stay the same, but my vertical asymptote will move to there, and this is what my new function will look like. Okay, he'll still be the same, but he's just moved 3 units to the right. Okay, so if this gets too messy, you know, don't put it all on the same coordinate plane or whatever. You can, I don't know, make another graph down here if you want to. Plus 4, this next function, again, this doesn't say up. A lot of people think that says up, but that would look like 1 over x plus 4 on the outside. So that's not quite right. The plus 4 is actually moving him to the left 4. Now, and another thing that people get confused with is plus 4. A lot of people think right or up, but when it's in that parentheses, which are kind of understood in this case, plus actually means to the left. So we're going to take that original point of 0, 0. I'm going to go to the left 4. So here's where he is. My vertical asymptote is here. My horizontal asymptote still is there. So this dot right here where he's left 4 just tells me where my vertical and horizontal asymptote go, or cross each other, I guess, and that's what he looks like. So my green one is the last one. Okay, that's kind of messy, but hopefully you get the idea of how that works, okay? So that's shifting a graph horizontally. All right, now I'm going to go to reflections. Reflecting across the x-axis or the y-axis. I'm going to change this function. This is the greatest integer function, those little brackety things, but I don't like to deal with that, and I won't test you over those questions. So I'm going to change this to be an absolute value function, okay? And we're going to see how this looks. So my parent function is going to be the absolute value of x. Y equals the absolute value of x, and he is just going to be a v, okay? There's my parent function. All right, and then I'm going to do my second one in pink. This negative is on the outside of the function. So when he's on the outside, this is a reflection over the, if you need to use your chart, you can scroll down or look at your paper next to you. It's a reflection over the x-axis. And then when the negative's on the inside, this is a reflection. Well, I cannot spell. Reflect over the y-axis. Okay, so we're going to reflect this over the x-axis, all right? So that's going to, the x-axis is this guy, and that's going to reflect him down this direction. It's going to stay the same kind of V shape, but he's going to be reflected down. Okay, I'm going to go to my third color, which is this guy. This is a reflection over the y-axis. Okay, now, the absolute value, let's talk about what happens with this. The absolute value of a negative number is the same thing as the absolute value of a positive number. So, like, let's say the absolute value of -2, that's going to be the same thing as the absolute value of +2. So by putting a negative in here, it's not really doing anything, because if I reflect this over the y-axis is this guy. So that means I take this guy and he's going to be flipped over there, and I take this guy and he's going to be flipped over there, and he's going to literally live on top of himself. And the reason why that is because putting a negative inside of an absolute value, inside of the absolute value, is not going to do anything. It's just going to make him on top of himself. Okay? Again, if I'm going too fast with any of this, please pause the video. Yeah. Stretches and compressions. Here we go. These are going to be vertical stretches and compressions, and then we have horizontal stretches and compressions. Okay? So looking at these two functions here, we have to identify the parent function. I'm trying to do it the same colors every time, sorry, if I'm not quite getting that right. Parent function, y equals, if I strip all of the numbers away, I'm going to be left with x cubed, okay? So y equals x cubed, if you look at your parent function graph, is something that looks like this. I always say he kind of looks like a parabola like this that's been flipped down this direction, okay? So there's my original function, and then if I do this guy, let's talk about what that 2 is doing. He is multiplying, so we know that we're doing a stretch or compression, but he is a vertical stretch by 2. And when I vertically stretch something, that's making him taller and skinnier. So what's really happening is this dot that's on my purple, this should be at 1, 1. It's kind of out a little ways, but this should be at 1, 1. If I'm vertically stretching him by 2, he should be at 1, 2. That's where he will be, okay? The point on the purple graph at 2 should be at 8, because 2 cubed, if I'm looking at my original function, 2 to the third power is 8. So on my purple graph, my original graph, 2 to the third power should be crossing up here at 8. So actually, if I multiply that by 2, 2 should be hitting at 16. Okay, because 8 times 2 is 16. So all the way up here is 16. So he's going to be really tall and really skinny. And do the same thing on the other side. That's kind of what he will look like. Okay, so that is a vertical stretch by 2. And hopefully you kind of got the gist of that. Okay, it might be helpful if I write those purple points in there. So this purple point is the point 1, 1, because 1 cubed is 1. This purple point here is the point 2, 8, because 2 cubed is 8. That's if I was doing that to the original x cubed function, okay? And then the pink is going to be just changed from that, all right? Last function, 1/4 x cubed. This 1/4 is going to be a vertical compression by 1/4, okay? So instead of this point over here being 1, 1, it's going to be 1, 1/4. So he'll be really skinny and really wide, like this, and like this. Okay, so that's kind of compressing him down vertically. You're making him closer to the x-axis. Okay, the 0.2 comma 8. This would be at the 0.2 comma 1/4 times 8. 1/4 times 8 is going to be 2. So this next point would be at the point, oh my gosh, technical issues here, would be at the 0.22. Oh, I made him really a lot wider than he needed to be. Anyway, so he is wider. He's a vertical compression by 1/4. Okay, let's go down here. I'm going to change these back to absolute value bars again, so we don't have to worry about the greatest integer function. And graph to absolute value of x. So my absolute value parent function is y equals the absolute value of x. If you want to graph the parent function, he looks like this. Okay, he's a v. The 2 is going to be a vertical stretch by 2. So instead of being over 1, up 1, over 1, up 1, over 1, up 1, we're going to go over 1, up 2, over 1, up 2, over 1, up 2, or this way, over 1, up 2, over 1, up 2, over 1, up 2. That's what my vertical stretch is going to do. Oh, I'm going the wrong color. Pink. Pink is my second one usually. There he is. Okay, and this one is just a little bit different because that 2 is in the inside there. This is going to be a horizontal stretch or compression. Now, on your chart, I told you to use the reciprocal. So when he's inside here, when that 2 is inside there, we're actually going to be using 1/2. So he is not a horizontal stretch. He is actually a horizontal compression by 1/2. Okay, so I'm compressing him horizontally by a factor of 1/2. Okay, so 1, 1, which was the original dot, I'm doing a horizontal compression, so I'm shifting him in. And what a horizontal compression by 1/2 is going to do is it's going to look exactly the same thing as a vertical stretch by 2. So he will live on top of, these two things are doing exactly the same thing, which a lot of times is the case. I think we wrote on our chart down here, oh, I erased it though, that skinnier and taller kind of went together and shorter and fatter kind of went together. So those two graphs are doing exactly the same thing. I am horizontally compressing him, so I'm taking this guy and I am making him half as wide as what he was before, which is the same thing as making him twice as tall as what he was before. Okay, all right, I'm going to skip example 7, but we'll do this one. This is the last one. There's a lot of things going on here. Holy cow, there's lots of stuff. There are actually 4 things happening in that, even though there's only 3 numbers. So let's list out the 4 things. 1, 2, 3, 4. Okay, there are 4 different functions that are happening. And the parent function, let's write out what he is. The parent, what I'm starting with is, I see these absolute value bars, so I'm starting with the absolute value of x, which is just this guy. Okay, and then we can figure out from there what all of the things are doing. Now, the underlying question is, does it matter what order you put them in? Yes, it does. Okay, so the 4 things that are happening are the -1, the +4, the 2, and the negative. Those are the 4 things that are happening. So I need to decide what order to put them in. And the order that you decide has to do with, this is just always how I go by it, this x right here. If I were to plug a number in for the x, would I do the negative, the 2, the -1, or the 4 to it first? Well, what I would do is if I'm plugging a number in for x, I would probably multiply it by that 2 first, right? And then I would subtract the 1, and then I would apply the negative, and then I would add 4 to it. Okay, so I just kind of yucked my paper up here. Okay, again, plugging an x in, I would take that x and I would multiply it by 2. So I'm going to put the 2 out here. Then, since these are kind of like parentheses, I would subtract the 1. So I'm going to do the -1 next. Then I would apply the negative, and then I would add 4 as my final thing. Okay, so let's talk about number 1, what that 2 is doing. That 2, since he's inside of parentheses, that is going to be a horizontal compression by 1/2. You take the reciprocal and horizontal compression by 1/2. Okay, the next thing that we're doing is the -1, which is going to shift him to the right 1 unit. Okay, the negative on the outside is a reflection over the x-axis, and the +4 is up 4. Okay, so that's a lot of stuff going on. All right, so I'm going to do a lot of dotted lines or a lot of kind of I'm gonna end up erasing stuff. So write really light on your graph. Horizontal compression by 1/2. I'm going to make him kind of like what we did up here. This was a horizontal compression by 1/2. He is skinnier than normal. Like he is half as wide as what he was to start with. So that knocks out this first one. Then I'm going to take that and I'm going to move it to the right 1 unit. Okay, so I'm taking this 0, 0, and I'm moving him to the right 1 unit. So he's going to be like this guy right here. He's skinnier, and he's moved to the right 1 unit. Okay, then I reflect him over the x-axis, so he's actually going down like this. Okay, and then I move him up 4. So I'm going to erase some stuff. So after my third step, I didn't mean to erase that guy. I just want that one. Okay, after my third step, he looks like this. And then if I shift him up 4 units, he will look finally like this. Okay, so there is that. Okay, that's combining all of those transformations all at once, and we end up with the graph of the pink. Okay, so that gets a little bit more confusing, especially when you have 4 of them at one shot. I think usually you'll only have about 2 transformations to do. But sometimes they will throw 4 of them at you all at once. But anyway, hopefully you guys got through that. We'll skip example 7. And there you go. The homework assignment that I signed for this, do not do that, because I am just going to embed questions into this assignment, and you've already probably answered all those questions. So have a good rest of your day, and I'll talk at you again tomorrow.